This is Mr. H. Just want to give you guys a little bit of help since I haven't been in for a couple days. First, let me go over yesterday's work. One thing you will notice about all of these is that there is no number or coefficient on the y variable on anything from yesterday. That's one thing all these problems had in common. And that's going to change on today's work. But first, let's go over a few. This one is on the board. So the idea, of course, is just to get everything in the same format, which we are very familiar with, which was y equals the slope times the variable x, and then plus or minus the y-intercept. Okay, so the idea is if the x or the slope is on the left side next to the y, we really want to put it on the right-hand side over here. So positive x minus x cancels it out. Just bring down anything that does not cancel. So we have y equals, and then put the slope right after the equal sign, negative x plus 4. And of course, negative x, we have to know that implies a negative 1x, which is the same as negative 1 over positive 1. A lot of things in play here. To graph that, start at the right-hand side of the equation. It's unusual that we always be thinking from left to right, but here we're starting from right to left. So first we start with this number. That's our beginning point. On the y-axis, y-intercept, at positive 4, 1, 2, 3, and 4. And of course, use the slope, rise over run, down 1, right 1, down 1, right 1. Continue the pattern until you have enough points to go ahead and make a nice straight line. And always use a straight edge when you're doing this. Don't draw them freehand. Nice straight arrows on both sides. So the line goes across the whole graph and all the points should be on the line exactly. If they're not, then you've made a mistake and you need to redo your slope. Okay, so all these are basically the same steps. Nothing out of the ordinary. Follow along with me if you still have this homework. Okay, so we can add 3x to both sides here. Since this is negative, I added. First one it was positive, so I subtracted, so you're always doing the opposite. We got 3x plus 7, which of course is the same as 3 over 1x. Okay, so we're going to start at positive 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. And then move up 3, right 1. So up 3, right 1. Of course, we can also do the same slope, but in the different direction. So 3 over 1 is equal to negative 3 over negative 1. Since the negatives cancel out, the right side equals the left side. They're equal. Now this is negative 3, which means down, and negative 1, which means left. So if we use that direction, we actually get the same line, as you can see here. So again, use a nice straight edge. Rulers are up on by the chalkboard. There we go. Okay, so that's last night's. Let's review these over here. So y equals 4. Notice how there's no x, which means there's no slope. Okay. No x means, implies, 0 slope. Meter slope. Okay. So I could rewrite this as y equals 0x plus 4. Okay, which means we start at 4 once again. We don't go up or down. There's no rise. So there's no up and over. We can put any number underneath we want, like 2. So like the run is 2, which means up 0 and right 2. So don't go up, just go right 2. Don't go up, right 2, right 2, and you can see a nice horizontal line. Excuse me. One thing about this equation, y equals 4, is that if you take any coordinate, right, this is negative 1, 2, 3, 4, 5, negative 5, comma, 1, 2, 3, 4, right, and this is x and this is y. So the y equals 4 here is the same as the y equals 4 here. Another way of remembering, is it horizontal or maybe vertical? All these have a y coordinate of 4. Okay? Y equals 4. Every point is y coordinate of 4. So the same is true over here. X equals negative 9. This is going to be the line that has all the x coordinates at negative 9. So go x equals negative 9. Remember, x-axis is here. Negatives to the left of the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's x equals negative 9. Here's another x equals negative 9. This is negative 9 comma 4. And here's negative 9 comma 7. So all the x values are equal to negative 9. Hence the equation x equals negative 9. So this is a vertical line. Okay, now the slope for these is technically undefined. Okay, undefined. Just write UND for the slope if you're asked that. And there's no way to use slope-intercept. Slope-intercept starts with y equals, right? But there is no slope-intercept. There's no slope, right? It's undefined. And there's no y-intercept since it does not cross the y-axis. That's why we cannot use slope-intercept form here. All right, so there's a review from yesterday. Go ahead and finish that up, and then you can get started on today's, which starts off the same. It's actually the number ones are the same problem. But then when you see over here, number 2, there now is a number right here in front of the y variable. That's what's new. So we're going to do the same steps. Start by moving the x to the other side. Okay. Cancels out just like before, but now we have 3y equals negative x plus 9. And we'll do one more step at this point, which is divide everything by whatever the coefficient is here. So it's 3, divide by 3. Divide by 3. So now the 3's cancel out, equal 1. So I have y equals 1y equals. Don't forget that this is negative x here is negative 1x. Okay, so last step, distribute distribute the 3 to both. We're going to divide the negative 1 and the 9 by 3. So negative 1 over 3. Negative 1 over 3x. Now, if these actually reduced 1 and 3, I'd reduce it. If it was like 2 over 4, I can make it 1/2, but 1 over 3 does not reduce, so I'm basically just rewriting it. Now, 9 over 3 over here, let's highlight this. So first I did this, got this number, and now I have this other one I have to distribute. So 9 divided by 3, right, that equals just 3. So the rule still stands. If you can reduce it, you must reduce. Negative 1 over 3 does not reduce. I left it the same. 9 over 3 does reduce, so I did. I got 3. Okay. And now from here, it's the same for graphing. Start on the right-hand side. Y-intercept is positive 3. And then we're going to go down 1, right 3. Down 1, right 3. Do it several times. Use a straight edge. Draw a nice straight line all the way across the graph. If your line doesn't go through all the points, then you've done something wrong. You need to try it again. There we go. So let's do a few more. That was number 2. Let's go down. Let's see here. Now, practice those. Let's go to the other side. Yeah, flip that over. All right, let's go ahead and do number 10. Add 3x to both sides. Cancel out. Bring down 7y. Bring down the equals. And then we have 3x plus 7. And the last step, divide by 7, both sides. Okay, 7 divided by 7 is 1. 1y equals, now distribute the 7. So we have 3 over 7, does not reduce, so just rewrite 3 over 7, x. And then we have 7 over 7, which does reduce to positive 1. Start on the right, positive 1. And we go up 3 and right 7. Up 3, 1, 2, 3, and right 7. 1, 2, 3, 4, 5, 6, 7. If we need to, we can go the other direction. 3 over 7 equals negative 3 over negative 7. So we can go back to where we started, positive 1, go down 3, right, and then left 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and make sure the line you draw goes through all 3 points. There we go. Go down to 13. I'll just do the solving part with you. Nothing really different about here other than that the coefficient of y is a negative sign. No number, just a negative sign. So we have negative y equals negative 4x plus 4. Okay, so the 4x canceled out on the left side. Common mistake here is to forget to bring down that negative. So you got to bring that negative, and of course a negative y is the same as negative 1y. So now we have a number to work with, divide everything by that number. Now dividing by negative or multiplying by negative just changes signs. Negative divided by negative, positive. Negative 4 divided by negative 1, now positive 4. Positive 4 divided by negative 1, now negative 4. So this negative 1 just changed these two signs. This one from negative to positive, this one from positive to negative. And of course we have to know that this 4 is 4 over 1. And then you can go ahead and graph. On 14, notice how there's no y on this equation at all. Conclusion, okay, vertical. So you can have this idea before you even start solving that, well, there's no y here, which means there's no slope. Okay, the slope is undefined, and there is no y-intercept, does not exist. D and E does not exist. And it's a vertical line. Oh, I already had it up there. That's why I was there. So when you go to start solving it, you kind of already know what you're going to end up with. So we got x equals negative 9 divided by 3, which is negative 3. And you know where to graph for that. Negative 3 vertical line. All right. Go ahead and skip this last part when it says graph by using intercepts. There's a special shortcut you can do if both the coefficient of x and the coefficient of y both go into this value. So like 3 and 5 go into 15. Over here, 1 and 8 go into 8, but we're not going to have time to get to that before the break. 4 and 5 go into 20. But if you want to go ahead and graph them anyway, that's fine. Okay, but they're not required. They're only required to go up to number 15. Okay, go ahead and use the rest of the period to finish up both of them and turn them in when they're done. Tomorrow you'll get the review for the test, and then we'll go ahead and do the test on Thursday.